Hi everyone, welcome to the Low Temperature Thermochronology course. Today, let's have a look at the fourth section of Chapter 6, the ICP MS Method. This lesson includes 4 topics, including introduction of the ICP MS method, procedures of this method, parameters and advantages of this method, respectively. ICP MS for direct determination of uranium-238 is a relatively new approach to fission track analysis. It is the first technique that has been able to compete with the traditional neutron irradiation method for determination of uranium-238 content in terms of high spatial resolution and ppm sensitivity. This development has added a new approach for fission track analysis, whereby uranium-238 can be determined directly in mineral grains rather than by using uranium-235 induced fission tracks as a proxy, as required by the EDM. The sequence of ICP MS method is illustrated in the red figure. The first 3 steps are the same as the EDM, including grain mounting, polishing, and then etching to reveal the spontaneous fission tracks. Prior to mount preparation, it is important to confirm that the mount size can be accommodated by both the microscope stage and the laser cell, as each laser cell may have specific sample dimension requirements. The spontaneous tracks are then counted manually or on sets of digital images that are required using an automated image capture system referenced to a coordinate system best defined by 3 mental disks with grids placed around the grain mount. The grain coordinates and the slide are then transferred to the laser ablation cell and analyzed by ICP MS. Most studies have used a single ablation spot of about 20 to 30 micron diameter around the area where the tracks were counted, as all of the tracks which are etched on the surface in zircon and apatite originate within about 5 to 8 micron of the surface, respectively. It is important to ablate the surface only to that depth, in case there is zoning of uranium in the vertical dimension. Uranium concentration is determined relative to suitable external standards of accurately known and uniform uranium abundance. For example, NIST 610 or NIST 612 glasses, and measurements of appropriate internal standards to correct for variations in ablation volume. These works also list operating conditions, but these are not universal and may vary with specific instrumentation used. Fission track ages based on the ICP MS method are usually calculated at an absolute age using values for all the constraints in the age equation. The ICP MS method has similar parameters with the EDM and considerable advantages over the latter one. Parameters of the ICP MS method are the same as the EDM. AFT retentive have some relationship with the content of elements which affect fission tract annealing to some extent. Habitat fission tract annealing kinetic parameters have been expressed in terms of diameter of H pits parallel to the habitat crystal C-axis, defined as dpar, which is most commonly used proxy for annealing kinetics due to its low cost and relatively ease of measurement. In spite of their limitations, dpar and chlorine content have been the recommended practical kinetic parameters to use for the interpretation and modeling of mixed multi-kinetic habitat fission tract samples. These parameters may be adequate if chlorine is the main element controlling factors for annealing. The LA-ICP MS method has advantages compared to the EDM. LA-ICP MS facilities are now becoming widely available, and this mode of analysis, as it no longer requires neutron irradiation and the long delays in sample processing. Other advantages of this approach are that it eliminates the need of handling radioactive material and as only one tract density measurements as the spontaneous fission tract density is required. It reduces the overall requirement for fission tract counting. With these advantages mentioned above, the LA-ICP MS method is becoming one of the two preferred dating methods and widely used. That's all for this lesson. Bye-bye.